Hi, in this video, I'm going to move to the next lesson on how to find limits of double integrals over general regions. Okay, let's see the theorem 2. Theorem 2 suggests that, theorem 2 say that type 1 region, the dA is dy dx, and type 2 region, the dA is dx dy. So if they say if the double integral dy dx means that it is type 1 region, and if the double integral of dx dy it suggests of type 2 region. Okay, how to find the limits? Later you have to first you have to sketch the graph. You have to sketch the graph. After you sketch the graph, you need to know how to look up at the graph. So how to look up the graph for dy dx? You have to look from bottom to top. From bottom to top. Okay, the line at the bottom here is the limit at the below limit at the below here, which is y equal to g1x, and the line on the upper suggests y equal to g2x, which is put at the upper limit. Okay, and the x is between a and b. A, b, and c, d here is a constant, yeah. So outer limit always always constant function only, constant only. Okay, next for dx dy, you look from the left to the right. So the line at the left become your limit at the bottom here. And so limit at the left, the equation would be x equal to h1 function of y, and the line at the right become the upper limit, which is x equal to h2 y, function of y, and the outside limit, which is y is in between c and d. You also can write this one, the x is in between h1y until h2y. Similar with dy dx as well. So you also can put the limit is in between g1x until g2 x. You can write your limit as like this or directly into your integral. Okay, let's try exercise. You can read the notes inside your book, page 94. But I'm going to explain you detail on example. For example, read the question first. Given as the limit, given this one, where the region R is bounded by line x equal to y. Line is mentioned here, line. This one, if you don't mention line, you should know this is a line because both are power of 1. X and y is power of 1. And this one is parabola. X equal to y squared. Okay, evaluate the integral over region R in the two ways, viewing R as type 1 region and viewing R as type 2 region. Let's start with type 1 region first. Type 1 region said that double integral dy dx. Okay, before we proceed with the solution, first you need to sketch the line x equal to 2y. Okay, x equal to 2y, when x equal to 0, your y equal to also 0. When y equal to 0, your x is also 0. So meaning that the intersection x axis and y axis is at 0, 0. Since the y, this one you also can rearrange. Y is equal to 1 over 2x. Since the slope is positive, means that your line will look like towards upward. Okay. I'm sorry. Okay, so this is your line. where please label your line so that you're not confused with the other line later. So this is your first line, and the next line, which is a parabola, x equal to y squared, x equal to y squared. Or for the sketching sketching graph, you can refer my previous video, which is part 2, so that you understand what I say on this video. Okay, next, x equal to y squared, you sketch. Okay, this one you can refer to the video, so you get this one, x equal to y squared. So I label it x equal to y squared. So the region is in between these two lines. The one that enclosed by these two lines, you can see it is here. It is here. So please shaded it. Please shaded it. So this is your region R, and label this is your region R. So you get your region R. Okay, this could give you 3 marks, one line 1 marks, and the region 1 mark. Okay, next, to get the limits. Okay, since they ask you to evaluate, means that they ask you to solve the given here, so we write the given there, double integral 4x minus y, and viewing as that one region, means that dy dx. dy dx, as I mentioned, you look from the bottom to top, not this, not bottom here, yeah, bottom of your region here. So bottom to top, I erase here first. Okay, bottom to top, bottom to top. Okay, the line at bottom, it's straight line. So equation of straight line should be at, so equation of the straight line, okay, it's a straight line at the bottom. So equation of this straight line should be at the limit at bottom. And on the top, you meet curve line. So the curve will be at the upper limit for limit at y. So in this case, we can see on the bottom is y equal to c. Okay, since it's y equal to something. Do you remember just now I said y equal to function of x. Okay, so y equal to, in this case, you can rearrange y equal to 1 over 2 x. So here become 1 over 2 x. y equal to 1 over 2 x. Okay, next, for the upper limit, you meet the curve just now. So the curve line is, okay, rearrange, y is equal to plus minus z x. Square, bring to the other side, have plus minus. However, since the graph is on top only, this is half of it, positive z x. This is negative z x. So since it meet on top only, so we choose the positive one, positive z x. Okay, the x value just, okay, the x value, okay, you just know the base and the top only. This one, you know the, oh sorry, you know the base and the top only. Okay, the region shaded is all over here. It might be half of this one. So which it represent by x. So if you want to represent all the shaded here, you need to have the limit for x as well. So limit for x, you just look at the x value. So meaning that from 0 until here. So to get this point, this is intersection point between the line and the curve. So to find intersection point, you have to solve simultaneously between these two equations. So solve simultaneously. Okay, I put it here, intersection point. You need to solve intersection point. You need to solve simultaneously between two equation, the two equation. Okay, so one of equation is y equal to 1 over 2x, and another one equation is x equal to y squared. Okay, so I put the value. Into, oh sorry, I choose the original equation. So the original equation is x equal to 2y. Okay, so I bring the first equation into the second equation. So I bring this one to here because solve simultaneously. So 2y equal to y squared. X insert into x here. So y squared minus 2y, you will get x minus 2y, I bring to the other side, equal to 0. So I factorize y minus 2y is equal to 0. So y equal to 0. Oh, another one, y equal to, oh sorry, there's no y here when you factorize. So you erase here. Minus 2. So y minus 2 equal to 0. So y equal to 2. So this is the intersection point. So intersection point, it's intersect at y equal to 0 and y equal to 2. Okay, the value of y means that here equal to 0 and y equal to 2. However, in this one, I don't want the value of y. I need the value of x because I need the limit for x. So how to get the point here for x is just insert the value here into the original equation. It's you can choose the first equation. You also can choose the second equation. It's okay. It will give you the same answer because both are intersection points, so it satisfy both equation. So when I put inside here, when y 0, x is also 0. When y equal to 2, x equal to 2y. So when y equal to 2, so the x equal to 4. So here is value of 4. Value of 4. So you see that the intersection point or the limit for x from 0 until 4. From 0 until 4. Okay, this limit represent your region R. Because as mentioned in theorem, this is your area, region is the limit. So limits is your region and your region is your limit. Okay, so here this is the limit. So you can solve now lah. Solve until you get the final value. However, for this video, I didn't specify or going to discuss on how to solve this one because I already discussed on the first video. So I teach you on how to start or to find limits only. So solve until you get the final value. Okay, this is for type 1 region just now. Okay, let's move to type 2. Okay, for type 2 region, okay, this is the same question, yeah. But I'm going to review as type 2 region. Okay, type 2 region, in the theorem said that it double integral your function, which is in this case 4x minus y, and your dA is dx dy for type 2. Okay, type 2, you look from left to right. From left to right. Because x is, you look like x axis lah. See, x axis from left to right, right? So you look from left to right, left to right. Okay, I write down here. Okay, from left to right of your region. Okay, line on the left, you will make the curve first. So the curve will become the bottom limit, and at the right will become the upper limit. So in this case, your left limit is from left to right. Okay, so the left limit is the curve, which is x equal to y squared. So x equal to y squared. And the right limit, the right line here is x equal to 2y. Okay, so you get your first integral. Next, okay, the shaded until where is it? From 0 until here, right? Okay, this is intersection point. Just now intersection point we already find it. So simultaneously between 2 points, you will found that it is intersect at y equal to 0 and y equal to 2. Y equal to 0 and y equal to 2. So your limit will become y in between 0 until 2. So this is limit for the region R, viewing R as type 2 region. So the answer is actually different, yeah, see, very different from for dy dx. You see the answer is very different from dx dy. So if you want to interchange the limit, you not simply just change it, you have to see from the graph so that you can know the limit only can be found from the graph. Okay, from the graph. Okay, next, continue. Okay, let's try the next example. Evaluate double integral xy dA where R is the region. If they ask you to evaluate, again, please do solve until you get the final answer. Here, I only teach you on how to find the limits only in this video. So how to solve, please refer to the first part of the topic video. Okay, for the second example. Okay, so we want to read the questions to evaluate this function where R is the region bounded by line y equal to x minus 1 and the parabola y squared equal to x plus 6. Okay, for this one, as I mentioned again, to find region R, you need to sketch first, then you can find the limit. Okay, to sketch this one line, okay, I find the intersection first. Y equal to x minus 1. So when x intercept means that y equal to 0. So x minus 1 equal to 0, x equal to 1. So y intercept x equal to 0, so y equal to negative 1. So y intercept at negative 1 and x intercept at 1. Okay, then I connect it. I will get the straight line. Okay, this is the line for y equal to x minus 1. We check by seeing the gradient. See, the gradient is positive, so of course the lines looks towards upward. Okay, next, this is the line, and next is the parabola. Similar, the parabola, I will find the x-intercept and y-intercept. So when y equal to 0, 2x plus 6 equal to 0, 2x equal to negative 6, and x equal to negative 3. So when x equal to 0, y squared equal to 6 and y equal to plus minus 6. Okay, plus minus 6 is might be over sorry, wait, I sketch it longer. Okay, one by one. So sketch the point first. Its intercept at x equal to negative 3. So let's say negative 3 is here, negative 3. And y-intercept at negative plus minus 6. So plus minus 6 be here, negative 6. You can use your calculator. If it bigger, smaller than negative 1, so it's become down here. If it bigger, it become up from the negative 1. So negative 6, and 6. Positive 6. So you get this one. You can just connect the 3 line at the 3 point. you will get parabola here. Okay, it's okay. It's just sketching. As long as I can see it's parabola, not straight line, should be okay. Please do only one line when you sketch into exam. Don't do like me, double and triple line. So just sketch one line, so that it clear, not messy, and not messy. So this one, please do label again. And for this one, the line is y squared equal to 2x plus 6. Okay, so I viewing this line. Oh, sorry, where's the region R? Region R, please do shaded the region R. The region R, you also, if you don't know, if you don't have a highlighter, you also can shade it, but like this. Okay, so region R. In exam, if you ask me, I like to shade it like this. Okay, region R. So region R, viewing as type 1 first. Let's say type 1 first. Type 1 first, viewing as type 1. Type 1, double integral. Okay, your function xy. Type 1 is dy dx. So dy dx. So y you look from, for y you look from bottom to top. From bottom to top. Oh, for this one, you see here, from bottom to top, from bottom to top. See, your base is have different line here, different line. So which line of equation line? Is it curve or line to be at the limit bottom here? So since this all is one region, so both base need to be at your region. So how to add the both region is by separate it as two region. And so I separate it as two region. I separate it here. So this one reviewing as region 1, this one reviewing as region 2. Okay, so region 1, so I put I put as double integral xy dy dx plus double integral for region 2 dy dx. Okay, since there is two regions, so at both you will get the full region here. Okay, viewing the first region, I highlight it so that you can see the first region. Okay, the first region, from bottom to top. From bottom you meet the curve, and the top also you meet the curve. So your equation of the curve will be y equal to, okay, bring to the other side, plus minus 2x plus 6. So y is between, okay, so plus minus, so the negative is bottom, the positive is on top lah. So your limit will be negative 2x plus 6, and the top is positive 2x plus 6. That is the limit of y for region 1. Next, the region 2, let's see, I choose pink color. Okay, region 2 here. From bottom to top. Okay, C from bottom to top. Viewing as dy dx or type 1 region. So from bottom, the line at the bottom, you met y equal to x minus 1. So y equal to x minus 1. And on top of the line, you will get y equal to the curve, which is, in this case, positive or negative. You will choose. Of course, the line on top is positive. So positive 2x plus 6. You cannot have plus minus. You have to choose either positive or negative for set value. Okay, next. Sorry, x minus 1. Okay, so the bottom here is y equal to x minus 1, and the top here is y equal to positive 2x plus 6 on top. Okay, so that is the first limit for region 1 and region 2. Now we want to find the second limit, which is the x limit, viewing as type 1. So x, the region 1 just now is from here to here, right? We want the x value, limit for x, limit for x. So we find that it's from here to here. Here you can see that it's is the point of intersection. Again, point of intersection you can find by solve simultaneously between the two equation. So the two equation here, solve simultaneously. Okay, let's see. I try to put the value here into here. So you will get y squared equal to 2x plus 6. So I bring to here. So y squared equal to x is equal to y plus 1. So 2x equal to y plus 1 plus 6. So y squared minus 2y minus 5 equal to 0. So use your calculator. So use your calculator for EQN to find the point of intersection. So 1, -2 and -5. You will get point of intersection at, oh sorry, I miscalculate here. 1, this one, if you expand it, you get 2. 2 plus 6 is 8. 8 bring to the other side is -8. So -8. So again, I calculate -2 and -8. Please do check your answer so that you don't careless. So you get y equal to 4 and another one y equal to -2. So the intersection point is at y equal to I put another color, so let's say green. Y equal to 4. Y equal to 4. The intersection point is here and here, right? So here is 4 and this one is -2. This is value for y, yeah. Okay, so how to find the value for x? As I mentioned, just put into your any equation of here and here or here, you still will get the same answer, which is if y equal to 4 or your x equal to 5 and when y equal to -2, your x equal to -1. So here is -1. Sorry. No, logical. Of course, this one is -1 because your 0 is here. And this one is 5. Okay. So, continue. So, your y. Okay, see your region 1. Again, region 1. From here to here. So, it's from -3 until -1. And for region 2 here, the pink color, from -1 until 5. So you will get -1 until 5. So this is the region, the limit for type 1. Okay, and then you solve until the end. Okay, let's try to view in the type 2. Okay, viewing as type 2. Type 2. Okay, rewrite your function double integral xy viewing type 2 as dx dy. So dx dy, you look from the left to the right, from the left to the right here. So this is the same question, yeah, the same question. So I just viewing as type 2. Okay, so from left to right. Okay, from left to right, from left to right, from left to right. Everywhere here, from left to right, it will meet this curve as a base, the same curve as a base, and the same line as the top. So you don't need to separate the region because it have the same base and the same top. It's quite different from viewing as this one, because this one have curve as base. This one, this part you have line as a base. This one, your base is from left, so left is have the same base, and this one have the same top. So you don't need to separate the region because it have the same base and the same top. So the base when you look on the left, okay, the equation of the curve is y squared equal to 2x plus 6. So we want to have equation of x, so 2x equal to y squared minus 6. So x equal to y squared minus 6 over 2. Make sure your equation of x equal to everything there. I want x only. Like this one, I want y only. So anything that I have in here, let's say squared, bring to the other side. Please bring to the other side. For this one, I want x only, so the other side become y squared minus 6 over 2 as the bottom limits, because from left at the bottom, left limit, left become the bottom limit. Okay, next, on top means that on the right, for the x dy, you look from left to right. So at the right, you have the straight line, which is y equal to x minus 1. So I want to view as x equal to y plus 1. So x equal to y plus 1. Just rearrange, you will get x equal to y plus 1. Okay, so this is the left and the right limits, and or you can say in the inside limit here for the x. Next is for limit y. For y, you found just now that it's intersect at -2 and 4. Just now you found at -2 and 4. So your limit, see here, is shaded from here until here. So the shaded until where is based on your limit for outside here. So y is between -2 until 4. So you can solve until the end. Based on this example 4b, you can see that type 1 region is quite hard to solve. The limit, it's quite hard to solve or evaluate the function if you view as a type 1 region. But if you view as type 2 region, it could be easier you to solve the function here because it's quite simple. So which type that you're going to use for the next question is depend on how the graphs look like. So please look carefully and understand carefully how the regions evaluate, how we evaluate the region to find the limit, especially on how to find the limits. Why? Because if your limit is wrong, of course others of your working will get wrong. So please do repeat this video. If you don't understand, please do text me at the WhatsApp.